Let's talk about the difference quotient. So here's where the difference quotient comes from. Let's say you had some function, and let's say we want to talk about the average rate of change from some point here, let's say x, to just a little bit over. And let's say the distance you move over is a distance of h. So if you start at x and then you move over another h, then I'm sitting at x plus h, which means the point right here on the graph is x comma f of x. And then the point on the graph here is x plus h, comma, f of x plus h. Now, I essentially want the average rate of change between those 2 points, which is the slope of this line. Well, the slope of the line is the difference in the y values divided by the differences in the x values. In other words, y2 minus y1 over x2 minus x1. That's my slope, which we usually use m for. And I'm going to go with this point over here is my x2, y2, and this point over here is my x1, y1. So I'm going to have y2 is f of x plus h minus my y1, which is f of x, divided by my x2, which is x plus h, minus my x1, which is just x. And you'll notice in the denominator that the x's cancel out. So my slope is f of x plus h minus f of x, all divided by h. This right here is what we call the difference quotient. It's used a lot in calculus to find the instantaneous slope of a line. The only thing that's missing here from calculus is a limit, but we'll learn about that in calculus. But for now, in algebra, we're going to focus on essentially trying to find the difference quotient and simplify, because frankly, that is the harder part of working with this aspect in calculus. So that's the difference quotient. So anytime somebody says find and simplify the difference quotient, you're always going to start with this. So let's find and simplify the difference quotient for the following. We'll do 2 of them. First one I'm going to do is f of x is equal to 3x squared plus x. Again, just so you can see it on the same screen that I'm writing on, the difference quotient is f of x plus h minus f of x all over h. So let's start with f of x plus h. So we're going to take this whole x plus h and plug it into the function. The function f is whatever you give it, you're going to square it, multiply by 3, and then you're going to add it again. I gave it the quantity x plus h. So f of x plus h minus f of x over h is going to be equal to 3 times the quantity x plus h squared plus x plus h. So this part that I've written so far is just the f of x plus h part. Okay, we're going to subtract off the entire function f of x, and to make sure I subtract off the entire function, I'm going to open up some parentheses just to help with that, and the function f of x is 3x squared plus x. So this part that I have right here is the minus f of x part. Last part, divide by h. So that's the difference quotient set up, but we have to simplify, so I'm going to expand, collect like terms, see what happens in the end. So x plus h squared is x plus h times x plus h, plus x plus h, and then send that minus through. I have a minus 3x squared minus x divided by h. You'll notice that in the next step after this, I have a plus x here, a minus x here. Those two are going to drop out. Foiling out the x plus h times the x plus h, I get 3 times x squared plus xh plus xh plus h squared. Plus x is gone again. Plus h minus 3x squared, all divided by h. So in here, there's 2 of those. This is 3 times the quantity x squared plus 2xh plus h squared plus h minus 3x squared, all divided by h. Next thing to do is to send that 3 through. So I get 3x squared plus 6xh plus 3h squared plus h minus 3x squared, all divided by h. You'll notice in this step that at the beginning I have a 3x squared and a minus 3x squared, so those two are going to go away. I'm left with 6xh plus 3h squared plus h divided by h. Well, now you notice everything in the numerator has an h, so if you factor out an h, you have 6x plus 3h plus 1. all divided by h. Well, now these are friendly multiplied, so I can cancel out these h's, and I am left with 6x plus 3h plus 1. I don't know about you, but that's about as simple as I can get it. So that is the difference quotient simplified down for the function that I had. One more example. Let's instead work this time with f of x is equal to 1 over 4x. Again, the difference quotient is f of x plus h minus f of x divided by h. So starting with f of x plus h, f is a function that whatever you give it, it does 1 divided by 4 times what you gave it. I'm going to give it f of x plus h. So I'm going to have 1 over 4 times x plus h because x plus h was what I gave the function. So that part is the f of x plus h. Subtract off f of x, I have 1 over 4x, and then I'm dividing by h. All right, well, fractions in fractions is about the only thing worse than just fractions, so I'm going to get a common denominator up there in the numerator so I can combine those two together and get this all down to just one fraction instead of fractions in fractions. So they both have a 4 in common, and then this one has an x, but this one has an x plus h. So essentially my least common denominator is going to be 4 times x plus h. So that's my common denominator, 4 times x plus h. Well, then from this first one, this first term, I was missing just an x. So 1 times x is just x. Minus, and then from this one, I was missing the whole quantity x plus h. So 1 times the quantity x plus h looks like this. Just make sure you keep parentheses around the x plus h because there's really a minus in front of the whole thing. And then it's all divided by h. Let's expand in the numerator of the numerator. So x minus h divided by 4 times x plus h, all divided by h. The x's go away, and all you're left with is minus h over 4 times x plus h, and that's all divided by h. Well, I'd like to divide by h. So if you think about h, it's really kind of like the fraction h over 1. So I'm going to multiply by the reciprocal of that. So I have negative h over 4 times x plus h, and then multiply by the reciprocal 1 over h. This looks like a negative h over 4 times x plus h times that other h. Well, now things are multiplied, so I can cancel out this h with that h, and I'm left with minus 1 over 4 times x plus h. And anything from there is just an argument of whether you'd like to send through the 4x through or not. Either way, that's about as simple as we can get it.